Hi, everybody. Welcome to the UCL lunch hour lecture on what happens to construction in cities after a flood. And quickly about myself, my name is Max Gunnebeck-Mönert. I am an applied microeconomist working at the intersection of urban and labor economics. I'm a lecturer at the Bartlett School of Sustainable Construction at UCL, and my research examines how housing policy shapes economic activity with a particular focus on social housing, rent control, and labor markets. And before we begin today's lecture, we'd like to briefly recognize that 2026 marks UCL's bicentenary, and it's an important moment for us as a community. And to open the event, we will share a short film that reflects on this milestone. After that, we'll move straight into the lecture. So please, film.
200 years ago, there was no university in London, and we're really marking the coming of a very radical, very different institution to a city that was the largest city in the world.
UCL was to be open to people of all faiths, or indeed no faith.
Women were admitted to the Slade School of Fine Art when it opened at the start of the 1870s, and from 1878 women were able to come to UCL, study alongside men and get a degree. And this was way before any other university was giving degrees to women.
In UCL's bicentennial year, you can expect a major new exhibition, 3 books, installations from renowned artists, and UCL Illuminated, a spectacular immersive sound and light show on our central London campus.
The main core is going to turn into a multi-day theatre with filming, workshop, lights, laughter, comedy, theatre and drama. It's going to be magic.
I'm really excited about telling people the story of how we as an institution have evolved over 200 years and how we're going to evolve for the next 200 years.
And now it is my pleasure to introduce today's speaker, Rodrigo Martinez Maza. Rodrigo is an assistant professor in economics and finance of real estate at the Bartlett Real Estate Institute at UCL, and his research sits at the intersection of urban economics and public policy, with a particular focus on housing affordability, housing market regulation, and urban adaptation to climate change. In his work, he combines empirical methods with a strong policy orientation, aiming to inform evidence-based approaches to improving housing systems and urban resilience. And before we begin, I wanted to let you know that we will have the time at the end of the lecture for questions. These can be submitted at any point during the talk by going to Slido, which you should have received in the invitation link, and entering the event code #construction. Okay, I will now hand over to Rodrigo for his talk. The floor is yours.
Thank you so much, Max, for the introduction, and thanks everyone for listening to this lecture. So this lecture comes as a result of a research that I did with some co-authors about what happens especially with constructions in cities after a flood. I will try to make it as plain in terms of language as possible, but if there is something that is not clear, please then post a question in Slido that I can try to answer. So the question is quite an important one because floods are the costliest natural disasters out there. So they account in the EU, for example, for 38% of all economic losses derived from natural disasters. They rank #1. In places like in Spain, they account for more deaths than heat waves and wildfires combined. And for example, also in Spain, they account for around 800 million euros every year to the economy, and they represent around half of all the insurance compensation requests. So here, a massive natural phenomenon, which is being also powered by climate change. The thing is that when we settle this problem from the economist point of view, if economic agents were updating the risk beliefs, we should expect that places that are regularly hit by these type of events, by floods, they should decrease in size, in economic importance over time, and that people choose to reallocate to safer areas. However, a lot of the evidence recently is pointing towards the exact opposite. The economic activity in flood-prone regions, they are not lagging behind, and in many cases they are growing more than safer areas. So why is this happening? So if we put this phenomenon into the Spanish case, we know that from 96 to 2021, areas that were prone to a flood and that were hit by a flood, they were growing 6%, almost 6% faster than areas that had not been flooded. So there's clearly something about the risk of floods or something that is very correlated to being flooded that is attracting economic activity. And this is important because climate change will make floods more frequent, more dangerous, and hitting new areas that were not hit by floods. And this is relevant because, for example, in Spain, and this is the case of almost every European country, we have a significant share of buildings that are very close to areas that have chances of flooding. So there is a question that I will try to answer today, and that what we did on our research was how do floods affect the amount, type of location of new development within cities, and how these urban layouts react and adapt to these natural disasters. So urban layouts is basically meaning how the city shape or the city as a whole adapts to these natural disasters. So what do we know so far? Let me walk you briefly through what the literature is saying and what this research that we did is trying to contribute to. So there is a lot of literature that focus on what happens with economic activity when there is a large scale shock. And this literature is quite varied. So for example, there are papers that look at how Hiroshima and Nagasaki recover following the atomic bombings in the Second World War. And for example, they show that they recover much faster than any other cities in Japan, and that in only a couple of decades, they were already as big or growing as much as before. There is a lot of emphasis, for example, on tornadoes and hurricanes in the US and how that affects the economic activity at a small level. One paper, for example, that you have there by Kokornik Mina, they focus on very large scale floods. So floods that displace thousands, tens of thousands of people. And what they see is that these areas that are being hit, they grow as fast as their counterparts following the flood. So people are not being pushed away from these areas despite them being more dangerous. There is quite a lot also about how these risk perceptions, they affect development responses. So how does new construction and the decision of where to live is affected by how people perceive risk? Some of the interesting facts that this literature finds is that, for example, in the US, insurance take-up increases significantly after your county is hit by a flood or by a hurricane, but that effect slowly fades within 5 years or something. So what it means is basically that people become more aware of the risk, but in the medium term, they forget about it. And they are acting just like before, even though they were hit less than 10 years ago by a hurricane. So what we are trying to bring into this literature is that we show, and I know that there are quite some hard terms there, but that the endogenous responses to these adverse shocks can offset the exogenous negative shock. In plain English, what this means is that the reaction of the cities after these negative events, floods, hurricanes, wildfires, they can offset the negative impact of this event and actually make the city grow even more. For that, we do kind of a long-run study, and we focus also on within-city responses. So we are not only looking at what happens within the whole city, but we are looking at what happens within the city, what is happening with development within the city, which is something that hasn't been studied before. And then we also, what I'm gonna talk to you about today is that we're gonna be identifying the heterogeneous responses for the urban layout with respect to the flood intensity. So not every flood is the same, and not every flood will cause the same effect. Let me walk you briefly through the data that we use for this research, because I think it's quite interesting. So all of this is publicly accessible data. So if you want to, you can also work with this data. And if you want to, you can try to replicate, or you can replicate all of the results that we get to this in this research, because it's all publicly available and we uploaded all the data and all the code needed to replicate what we do. So we have data on the universe of buildings in Spain. So basically we have every building in Spain, and we know the exact geolocalization. We know some basic characteristics like when it was built, what kind of use does it have, whether it's residential, industrial, agricultural, etc., and how many square meters does it have. So that's around 30 million georeference units. So it's a very large data set, and you can see it plotted here, which what you are seeing basically is a plot of population density, so where buildings and where people are located, what you can see here on the map of Spain, and it has a zoom on Malaga, because I will show you later a map of Malaga, in which we basically combine all of the data to see how it looks. Then we also have very detailed information on floods. So fortunately, Spain has been keeping track of flood records for quite some time. So you have some floods even recorded in medieval period. We only focus on 1996 to 2021 because that's where the data is, let's say, safe. But the problem with data on self-reported floods, so that a municipality says, I've been hit by a flood, is that it's not exactly random. Or let's say the municipalities that choose to report a flood, maybe, for example, the ones that are wealthier, larger, and those that are poorer may not necessarily report the flood. That creates some problems for our identification strategy, for our methodology. So what we do is we complement this with publicly available data on rainfall. So the Copernicus project has a 0.1 degree resolution, so that's very small grids that they basically base across all of Europe. And you know exactly in that grid for every year how much rainfall there has been. So it's really, really good and very granular data. You have it for several decades. Then, due to a EU directive that came in 2007 that basically said that every EU country needed to create floodplain maps. So these floodplain maps are basically maps that say whether an area is likely to be flooded once every 50 years, once every 100 years, once every 500 years. And so basically what the purpose of these maps is to signal potential risk for population, and then also to create regulations around what can be built and what can't be built on these areas. For example, in most EU countries, you cannot build a school within a 1 in a 500 year zone or area. So that's basically to protect people from this risk exposure. We also have some detailed terrain elevation data from satellite images, and we complement this with some census and data from national statistics at the municipality level. How does it look when we put all of our data sets together? So this is the city of Malaga, if you don't know it. So around here you have the sea, and you have the mountains nearby. And as you can see, you have every river, and then also every floodplain in the area. So most of the city is here, and it has rivers coming from the mountains. Here is this big blob here is the airport, but as you can see, you have a river here, the Guadalhorce, one of the largest ones in Spain, that has a significant floodplain. And as you can see, these small rectangles here are buildings. So there are buildings that are built within the floodplain that have a significant risk of being hit by a flood. So basically what we're going to be looking at is when there is a flood in a municipality like Malaga or like any other of the around 8,000 municipalities that are in Spain, what happens with new construction? Should we expect new construction to occur on higher ground that is technically safer? Do we expect it to move away from floodplains in areas that are safer? Do we expect it to decrease at all? So less is being constructed. So that's kind of the intuitive question that we are trying to answer in this research. The thing is that I need to say something about floods, because when we think about floods or when we speak about floods, we tend to think of like very large destructive events. So many of you probably remember the very large flood that happened in Valencia in 2024. That's one of the largest and more destructive floods in Europe's history, and is particularly important, or let's say notable, not only because the number of people killed was very large, over 200 people killed, but also it was one of these flash floods. So it was a massive amount of rain in a very short period of time, very, very concentrated, that basically overflows any type of capacity that the city can have in order to deal with this flood, and then it creates massive destruction, right? But the thing is that floods are not always that kind of destructive. So in this table, what I put is according to the level of rainfall. So how we measure floods is we see how much rainfall there was in a specific period of time, and that tells you that is a very good proxy or a very good approximation for how intense or how destructive a flood can be. So the one in Valencia, an absolute massive flood, imply over 600 millimeters of rainfall in a single episode. But there are other types of floods. So for example, you have one that can be over 140 millimeters. That's something that will reach national news. You have one people died in Valencia, towns that are isolated for several days, massive damage to infrastructure, widespread destruction of residential commercial properties, and it's recorded as one of the most severe floods in years. But then if you go down, you can see that the level of destructions decreases, right? So for a flood of around 120, 140 millimeters, you would expect several people being evacuated, but not necessarily people dying, significant damage. If you go down, you can find school evacuations, highway closures, flooding the city centers. But then if you go down to around 40 millimeters, which would be more or less a heavy rainfall, you can expect some weather warnings, but not necessarily damage. If you go to 60 or 80, you can have some damage on some type of infrastructure, but you can also see that the news coverage usually doesn't go. And I also want you to look at how non-linear these responses are. So non-linear here meaning, if I move from a flood from 80, that is 80 millimeters, so let's say this one in Albalate del Arzobispo, and we jump into one that is 160, so twice as much rain, that would put us around here in Orihuela, Valencia, you can see that the level of damages is not twice as much, it's several times larger, right? We move from minor damage to one highway to people dying, several hundreds of people being evacuated, widespread destruction. And the thing is that climate change is likely going to push the severity of these rainfalls, and therefore the damages are not going to increase linearly, they are going to become larger and larger. So the core of the methodology, let's say, is trying to think, okay, how can we actually answer the questions that we were saying, right? How is a city affected by a flood? And the strategy here I'm trying to put this in intuitive terms, is that we compare similar cities over time. So basically, we're going to compare two municipalities. They are both being hit by a flood, but one is being hit by a flood sooner than the other, right? So the question is, kind of how does a city change after a flood compared to other similar cities that are changing over the same period. And this methodology is quite standard within economics and is called as difference in differences. So we basically end up with, let's say, two large groups of municipalities hit by a flood, not yet hit by a flood, and we see how they behave before the flood and after the flood. So this methodology comes quite handy because we are comparing places that are similar in flood risk, right? Because imagine you want to compare a city that has a river that can flood with a similar city that also has a river that can be hit by a flood. And you're just playing with the timing there. The whole assumption of our method is that the time in which a city is affected by a flood is as good as one. So basically, we have the cities coming from 96 to 2021, and we say they are very similar cities. It's just that one of them is going to be hit in 1998, one of them is going to be hit in 2005. But they are really like good comparisons. The only thing that changes between these two cities is when they are hit by this flood. So doing this methodology, we can compare and track what happens before and after the flood. And it also kind of helps us isolate or determine the effect of the flood itself from other economic changes. Because imagine that from 96 to 2021, there are plenty of things happening in the economy that can affect construction, right? So we have for example, the Great Recession there, the Great Financial Crisis in 2008 happening that has a massive impact on the construction industry in Spain. So we want to be able to account for these effects, so that's why we implement this methodology. So again, the idea here is that we are following cities before and after a flood and compare their evolution to similar cities that have not yet experienced one. So again, we want to compare cities, for example, Malaga, that has a river inside we can compare it with Valencia, that also has a river. But the thing is that Malaga, for example, is hit very early in our sample, around 98, and Valencia is hit late. So our assumption is, if Malaga would not have been hit by a flood, it would have behaved the same way as Valencia that was hit late. So that's kind of the counterfactual that we try to construct, because that's something that we cannot observe, right? The thing that we cannot watch is what would happen to a city if it wasn't hit by that flood. Given that that doesn't exist, because it's a hypothetical question, we need to try to construct it, and the way that we do this is with this methodology. So let me walk you through the results, and first I would like to start by saying how we should read these graphs. What this graph is basically what we call an event study graph. Basically, what we do is we plot every coefficient with respect to how many years have passed since the last flood, which is on this right-hand side, and how many years are yet to come since the flood hits that are on the left-hand side. And so this is showing the log of the surface spill. So basically how we read this coefficient is that we say 10 years after a flood, there is around 7.8% more built in that municipality than right before the flood. So as you can see, there is this red line, which is our kind of comparison period, which in this case is the year immediately before the flood. So all of these coefficients are read with respect to that previous year, right? So 15 years following the flood, a city is on average around 9% larger than what it was right before the flood. And the good thing about this methodology is that it allows us to answer this question causally. And causal interpretation or causal inference is something that we use a lot in economics. It's basically, causality means that something causes something else. And the whole of the methodology is trying to be able to say this confidently in a rigorous way. So all of the methodology, all of what I was speaking about, which cities, which municipalities we compare to each other is in order to be able to say, being hit by a flood increases construction 10 years after the event by around 7.8%. Okay, so the first result is already quite counterintuitive, right? So being hit by a flood increases construction, and this effect also shows up quickly. So you can see that even on the year after following the flood, it's already there, and it persists over time. So what it means is that the shape of this curve doesn't go back to zero. Usually when we say that we go back to zero, the effect fades, right? But we see here is a large effect, so around 10% larger, or because being hit by a flood, and that this remains over time. So basically what we are finding is that rather than shrinking, the cities are expanding, are becoming large. Okay, so we saw what happened with development. What is happening with the shape of the city? What we find, and you can see there here, even if it's a bit pixelated, is that the cities become more compact. This is a disconnection index. A disconnection index is something fairly standard in economic geography, but basically what it does is measures the distance of each building in the city to any other building in the city. So the more compact a city, the smaller this disconnection index is. The smaller the average distance between every two cities. Now, imagine that you have to measure the distance between every two buildings in a city. That's computationally super demanding. Because imagine if you have a small town, 50,000 inhabitants, let's say 10,000 buildings, then that's already a lot of computations that you have to make. Because for every building, you have to compute 10,000 distances, right? So this took quite a while to compute. But we are saying here is that a flood 10 years later makes cities around 3% more concentrated, more close together. So what this is showing is that these urban areas are becoming more connected and more compact. And again, this effect is persistent over time. So it means that these cities become more compact and remain more compact with time. So again, these floods, what means is that floods lead to denser urban development and not necessarily the cities expanding geographically, but rather more concentrated. A common question is like, how is the landscape changing in the city? And what we do is we basically measure the average height of every building. So we know exactly from the database that I first talked about, we know exactly how much every building, how many floors there are in every building, so we can more or less compute the height. And what we see is that these cities are becoming taller. So it means that the municipality is hit by a flood, and it builds more compactly, and it does so with taller buildings. So basically what it means is that part of this response to flooding involves intensifying the use of the developed land. So it's not necessarily taking new space. Now, these results can be a bit abstract. So I wanted to show you this on a case study, right? So let's go back to Malaga. Now we are focusing on the neighborhood of Campanillas, right? Campanillas is a relatively poor neighborhood within Malaga. In 1996, it's hit by a flood, and which meant that basically the river Guadalhorce increased by approximately 1 meter. Don't think about this of a massive destructive flood, right? So we have some buildings that are damaged and 2 people that were injured, right? So a relatively small level, let's say, flood. And what I wanted to do with you is that let's try to see whether you can guess where the new construction is going to be. So if you want to, you can go in your phone, you can go to Menti or in your computer. With your phone, you can scan the QR code, or in your computer, you can go to Menti and put that number over there. What you will be able to see there is, I will show you now, is basically the map of Campanillas that I just showed, and you're going to be able to pinpoint in the map where do you think the new development is going to take place. So basically, where do you think that the new development will be located after this flood? So you should be able to pin on the map that you're seeing. So I can see one reply there. I can leave some time for you to think. Good. So I see some people, so quite different answers. So I see that some people are putting toward areas close to the floodplain. So exactly. So the blue zone here is the areas that is dangerous, that is likely to be flooded. And you can see the river going in the middle, of course. And the gray dots are all the buildings that had been built before 1996. So I can see that some people put close to there, some people have also put inside the floodplain, and some have put on this apparently higher ground, slightly further away from this floodplain. So shall we see the results then? What happened on this? So here, for example, I put in red the new construction that happened between 96 and 2005. So on the 10 years following that flood. What can we see? First, that there is a lot of new construction, right? There are plenty of new buildings following the flood. Then that it tends to follow really closely the areas that had already been built, right? So you can see all of that area was already built, and we are just putting kind of red dots closer to gray dots. Also, that we have a lot of construction on areas that are likely to be flooded in the future and that were likely hit by the 96 flood, right? These areas are really close to the river and are dangerous, right? And we don't have, for example, a new neighborhood coming up here, away from these dangerous areas in safer ground. We don't have new neighborhoods here. They just tend to follow what was already built, and a lot of it is built on these dangerous areas. So this is exactly what we were saying on the previous results, right? That you have these kind of results. So I want to show you a bit more on these results. So the thing that we also find is that the floods can change the mix of buildings within a city. So we know exactly the use of each building. So we know whether it's residential, industrial, whether it's used for offices, for retail, for agriculture, public, and so on. And what we see is that there is a jump in residential buildings. So it's mostly basically flats for people to live in, because in Spain, the vast majority of the population lives in flats. And there is a decrease in industrial and agricultural buildings. So it looks like cities are becoming more oriented towards housing and service sector activities. So overall, this is pointing that these cities hit by a flood are becoming more attractive places to live and work rather than just recover. So it's not only like they are able to recover from the flood, they are growing more after the flood. So in order to make sure that, okay, so if we see, for example, an increase in residential buildings, we would expect an increase in population. And that's exactly what we find, is that On average, flooded municipalities, they end up with 9% more people living there than those municipalities that were not hit by a flood. So this is what this red dot is showing. It's basically the effect on the population, that is almost 9%. And as you can see, the effect seems to have some kind of spillover, so that municipalities that are close to the one affected by the flood, but not flooded themselves. So basically, your neighbor municipality got flooded, but you're fine. They also have some level of increase in population. Where is this population coming from? It's coming from those municipalities that are further away, around 20 to 50 or 60 kilometers from that. So these municipalities, they are hit by a flood and they are attracting population from other municipalities. So it's not only about rebuilding the damaged properties, people are choosing to live in these locations, which means that there is some increased attractiveness in these cities. So we have more construction, more people living there. And what we also find is that we have higher housing prices or property prices. So it's not that the flood is not making these areas less attractive, it's actually quite the contrary. So after we control for building characteristics and the location, we find that property values increase following a flood. So 15 years after a flood, we see an effect of around 20% more housing values within that municipality. So it looks like it's potential that the reconstruction period that follows the flood is improving the local amenities, the infrastructure, the neighborhood quality, and overall this is attracting more people, more construction, increasing the value of this property. So in order to kind of wrap up the big picture of what's happening in cities, is that we also find that unemployment falls relative to other municipalities, and it's basically entirely being driven by services. So as you can see, the share of people unemployed that work in the service sector, which is the main sector, by the way, in Spain, decreases significantly. So you're having basically more economic activity following the flood. More people living there, more construction, higher housing prices, more residential units, lower unemployment. So, but what I wanted to say also is that not every flood has the same effect. Some of the results that we find is that the rainfalls that are less than 80 millimeters and over 140 millimeters, they trigger these responses that are much, much smaller. So it basically means that there appears to be an area of, or let's say, a range of intensity of the flood that can create these positive effects. What we think is that if you have a flood that is too small, you don't really get much going on, enough to change the dynamics of the sea. If you get a flood that is way too destructive, the negative part is way larger than the potential positive effect. So there is a point there is a range that flood can trigger these positive responses. We also see that those frequent floods, so that those that happens within 30 years of each other, are driving most of the results. So it's not necessarily the 1 in 100-year flood on an area that hadn't been flooded for many, many decades that is driving this result. Those are relatively common because we think could be building some resilience in the city. And we also see that kind of, as in the case of Campanillas, as I was showing, the new development happens mostly around the areas surrounding the floods. So it's not this new construction within the city is not happening on higher ground away, but really close to the flood. So again, the positive effects will happen only if the destruction is not too large. It looks like people learn from these floods and adapt and become more resilient, but up to a limit of around 30 years. And that development happens in areas that are likely going to be flooded in the future, which is a major concern when it comes to policy. So I wanted to wrap up kind of trying to answer the question, okay, why is this happening? What could be the potential mechanisms here? Well, we know that reconstruction can lead to a wider process of upgrading, right? So you have a damaged house and you repair it and you renovate it. And what literature shows is that if your neighbor renovates their house, you are more likely to renovate yours because you want also to be better, and it has kind of this spillover, positive spillover. If there is a flood, you can have improvements on infrastructure and public spaces, and particularly relevant for Spain, you have insurance payers. So in Spain has a very universal coverage on insurance, and basically you're mandated to have insurance coverage. You pay a relatively small prime, but if you're hit by a flood, you will get the money quite quickly. So you can use that money to renovate your house, and that can lead to the positive effect. So that's what we are trying to test, whether the reconstruction and upgrading of these units is driving our results. If that is the case, then we would expect more development on those areas that have more insurance payers. And that is roughly what we find. We find that more development responses are happening on those areas that receive larger insurance payments. So this pattern is kind of consistent with adaptation and rebuilding, kind of serving as an stimulating for new investment. So what this is suggesting is that these floods, they can set in motion processes that go well beyond just reconstructing what is damaged. They can trigger kind of this positive economic response that is driving our results. So floods, for sure, can be destructive. We're not saying no. But the thing is that the new construction, the response that comes after, can improve the quality of the local neighborhoods and can create these positive spillovers, positive amenities. So this improvement, they can bring new development, and they can lead to denser and larger urban areas. Another potential mechanisms that we're saying is that, well, rebuilding after a flood requires resources, right? But these resources may not necessarily be enough to make new development. The thing is that we think that, or let's say, think about two cities, both being hit by a flood. One is a high demand city, somewhere that people want to live there, in which housing prices are high, housing is scarce, and it's very profitable for developers. And you have another, in another hand, a city that is not growing, is stagnant, population may be decreasing, there is not a lot of demand for housing there. If both of them are hit by a flood, what we think is that the opportunities for redevelopment, more construction, and people moving there are going to happen on the areas that people want to live there, on the high demand city, or on the wealthier municipalities rather than on the poor ones. And that's kind of exactly what we find. Again, this positive effect is being driven mostly by the wealthier municipalities. So those municipalities that have high pre-existing property values that were very demanded before the flood are going to be the ones that are going to be benefited by. So again, this kind of, what it shows is that these inequality problems can increase with floods. So floods can make wealthier areas more wealthy and poorer areas poor. And this is in line with something that has a completely different context, which is the Katrina hurricane in New Orleans in the 2000s. What it showed there was that, for example, the areas that were hit by Katrina that later recovered were those that have higher housing demand. So the wealthier areas managed to recover after Katrina. But many of the poorer areas were completely abandoned. So they were not able to recover at all. And there are still many ghost towns within, close to New Orleans, that have not been able to ever recover from this impact. And this is in a similar line. So we are not focusing on one event. We are using many floods, and we are not only using the super destructive event as Katrina, we are using smaller scale floods, but still is pointing towards in the same direction, that reconstruction and redevelopment will happen on those areas that people were already wanting to live in there. And for those that were lagging behind, they are going to lag behind even further. So to wrap up, what we were saying is that we took data on every building constructed in Spain between 1996 and 2021. We studied how cities change after experiencing a flood. What do we find? That floods are followed by more construction, denser cities, and more vertical as well. That there are overall positive impacts from floods that go from property values, population increase, decrease in unemployment, and more services. Worryingly, let's say, growth is not moving away from flood-prone areas that it's locating right on. And we know that the strongest positive response following a flood happens in places where demand was already high and that they receive a lot of insurance compensation. So floods can be destructive events, are destructive events. We're not trying to paint a positive view of floods here, but we need to understand exactly how they impact cities in order to protect cities better in the context of increasing the increasing intensity and frequency of this disaster event with climate change. So floods are destructive events, but they can also trigger adaptation and rebuilding processes that can reshape the future of this city, right? So the question from my research, and I hope that you also feel the same, or at least you can let me know on the question, is that are we adapting or are we increasing future risk, right? Because from what I show is that rebuilding and growing is the rebuilding and the growing of the cities is happening on areas that are exposed to these floods, right? So what is happening? These are the households, firms, and the government not really taking into account the future risks. Can it be that the post-disaster redevelopment are making communities more resilient because they are more dense, so they could stand this potential impact better? Or on the other hand, what is making is that people are being drawn into these dangerous areas, so we have more people, more assets concentrated in potentially dangerous areas, right? So climate change, as I was saying, is going to increase the frequency and the severity of these extreme weather events. And again, something that I want to say, think of floods as an spectrum, right? Something large that can be very destructive or can be relatively mild, right? But understanding how people in general respond to risk is quite important, because we need to think about not only the hazard itself when developing these policies, but also the behavioral response. And designing policies that promote adaptation without increasing this future exposure remains a major challenge. Okay, thank you. I think that's all for me. If you have any questions, you can scan this QR code and post it. And I think now we're going to go through to the Q&A.
Yeah, so thank you very, very much, Rodrigo, for this great presentation. We have some questions from the audience. So let's start with one asked by Alex, and he's asking if you could comment a bit more on potential implications, for example, for infrastructure delivery plans. So are they also affected by these floods, like governmental investment, and how would we expect this to kind of unfold within the broader evidence you just
Right.
displayed?
No, that's a good point. I mean, a lot of it is also, this is kind of considered from the point of view of the government and the policy making here. So the thing, for example, the paradox around public infrastructure, and especially that is aimed towards decreasing the risk associated with floods, is that you can build, for example, a flood dam in a city, but what that will make is that it can signal that that area is now safe and it can attract more people into that city. But if that infrastructure is not actually capable of handling the worst case scenario with climate change, what you're actually doing is exposing more people to worse risk, right?
Mm-hmm.
So there is quite a lot of evidence, for example, for the US, that when the government declares the emergency on a city and it sends a lot of funds, what it actually makes is that that more people will live in a city that is dangerous, right? And in the US, for example, that's a case for hurricanes, in which you have very little infrastructure that you can do to prevent or to protect from that, right? So the government can try to help and recover an area, because that's what they will try to do, right? Develop policies to try to make areas that have been hit by a natural disaster recover, but it can have the unintended consequences of attracting more people to these dangerous areas. That's something important to take into account.
All right. Yeah, I agree with you. So when we think this actually that's a good point. So this brings us to the next set of questions, which I'm going to summarize a bit. They also asked like by a different Alex, and they go in the direction of how mechanical are these effects in a way, right? So you propose a mechanism through saying like, okay, there are now insurance premiums paid to like these localities affected by floods. People use this to revamp construction or rebuild the city. So I think the first point we would like to highlight, or like let's summarize these points he's mentioning in one question. The first point is, how mechanical is it just well, now you have money, you can just rebuild your property. And the second one is higher prices also. Is there evidence that insurance premiums are increasing, which would also like lead to higher construction prices basically in the future? So
Right.
question, is it really like more demand now, or are these areas more demanded, or is it just mechanical because now it's anyway becoming more from a supply side, more
Right.
easier and also eventually more expensive to build there?
No, that's a good point, definitely. I mean, I think it's probably a combination of two. So first, you have a mechanical effect that this is what I'm saying. You get hit by a flood, so you have a source of income coming from the insurance payments, right? And this is particularly true for the Spanish case. And I think that that's kind of something that we need to take into account when thinking about these results. Spain, as France and some few other countries, have this fairly universal insurance coverage in which you pay very little relatively. You are mandated to have insurance against different risks. But then the insurance system works fairly quickly. So, for example, take the case of this massive flood in Valencia that happened in October 2024. We're talking about billions of euros in damages. Something like the 80–90% of it was paid within the first 5 months. Now, if you have car insurance, you know how long it can take to receive money from a small scratch. Imagine having your house completely destroyed by a flood and receiving full payment for insurance within the first 2 months, right? So it can be that the first kind of impact or the first positive effects that we find following the first few years are driven by these insurance payments. But the thing is that what we see is that the effect is quite persistent over time. So it's likely for this to trigger some kind of positive reinforcement, right? So that this money brings more money because it brings new construction, because it brings more people to stay, lower unemployment. So kind of sets the ball rolling. And these places become more kind of attractive to live in and more economically dynamic, right?
So, but then to interpret this, then my question, I think, or the question I would have as a follow-up question for this is how, if you think about that, you say, okay, there is a behavioral response, let's say, by individuals and developers to move into these areas. How should we think about this? Is it then that individuals or economic agents underestimate flooding risk in this sense? Or is it that this is just adaptive behavior?
So yeah, I mean, that's really interesting. Why is this happening? So we don't have evidence on this for our research, but it's likely to be part of it is people are myopic when it comes to these risks, which means that they cannot understand the level of risk that they are really kind of involved in, only whether, for example, you are within the floodplain and you have like some kind of certificate that says that you are in a dangerous area, but you still, for example, you may not really think about how real that risk is. So, for example, living in a 1 in 100 year floodplain area is really, really dangerous. And people underestimate, even if it's on the name, how often you're going to be hit by a flood. If you're in a 1 in 100 year floodplain, it means that you have a 50% chance of being hit within 50 years. So within your lifetime, living there is basically tossing a coin whether you're going to wake up one day and you're going to have water up to your ceiling, right?
Mm-hmm.
I think that people tend to underestimate a lot this. And the next thing is that sometimes incentives from the one who builds versus the one who's living there are not necessarily aligned.
Mm-hmm.
So if I am a developer, I need to build a house and sell it. And after selling it is someone else's problem, right?
Mm-hmm.
And then if I have someone buying, then that's the risk, right? But if you're a buyer trying to move to a city and you only have the available units in dangerous areas, you're likely going to end up anywhere there because there is no supply, because you're not the one kind of marking the supply. And for example, if you're a renter, you're not going to spend in that house, in that flat for a long time. So maybe you don't care so much that is on a slightly dangerous area, right? So you see the incentives here can misalign and it can lead to lower level results or lower societal worth.
Mm-hmm. That's a great answer, and I would love to elaborate more on this, but I think we have basically time for one more question. I think it's a very important question, and it's asked by Helly, and she would like to ask basically, do you think some cities are better positioned than others to adapt to recovery from flooding? So, for example, are there some city characteristics besides, like as you mentioned, this heterogeneity by like rich and poor neighborhoods, but are there some characteristics inherently by cities which would allow them to react differently?
So I think that that's an interesting point. And for that, in order to answer that properly, we need to think about what type of floods you can have, right? So I mentioned this briefly, but one thing is being flooded by a river in your city, which is one of the easiest way to solve. You can put dams, you can improve the flowing of the river. You can do some works in order to make a river safe. That has been done for many thousands of years already. You can have floods coming from the sea, which you can also implement infrastructure, which tends to be quite expensive in order to put defenses against floods. But the type of flood that is going to become more common is the one that is hardest to protect. That are these flash floods.
Mm-hmm.
Floods that is basically massive amounts of rain, a year worth of rain falling within 4 or 5 hours in a small area in a city. For that one, there is very little that you can do to absorb the massive amount of water that you can have. So, for example, in the case of Valencia, there was very little that Valencia could have made itself to prepare for such a flood. You just have an amount of water that cannot really be managed. You can prepare to deal with, let's say, lower level flash floods so that the drainage within the city improves, but it's a lot of investment that you need to make.
Mm-hmm. That's a very good answer. I think it's also very beneficial for your identification strategy. Giving you like this surprising shock to which you cannot really adapt. So thank you very, very much, Rodrigo, for presenting this great and important research. And before we finish, I'd like to highlight that UCL is celebrating its bicentenary this year. And if you're interested, you can explore the UCL 200 events program. You can join us on campus for walking tours, or you can visit the UCL 200 exhibition. And we also have 3 new UCL 200 publication. All of these are linked on the UCL 200 web pages, and you can access them simply by scanning the QR code you can see on the screen here. And by this, I would like to thank you for joining and have a great day and see you for the next lecture.